Hi students, in this video we're going to look at how to solve equations that have variables on both sides of the equation. Alright, so by the end of this video you should be able to recognize like terms in the equation and then be able to collect them and help you solve equations where variables are on both sides of the equation. Alright, key things to remember are the distributive law, shown here. So remember we've got 3 times what's in brackets here. That means you have to do 3 times x, which is 3x, and 3 times positive 2, which gives us positive 6. Distributive law, remember that one. Remember your key steps for solving equations, order of operations but in reverse, and then using inverse operations to create equivalent equations. And finally, remember like terms have to have the same variables with the same powers. So 5x and 8x are like terms. They both have x's and only one of them each. However, 5x squared, x, and negative 3xy, they're all unlike because they have different variables, and even 5x squared and 8x, the variables have different powers. So they are not like terms. They cannot be added or subtracted. Now, when solving equations with variables on both sides, the key step is to add or subtract one of them from the equation, making an equivalent equation that can be easily solved. Now, as far as which one to use, there is no wrong answer. You can pick either of the terms involving a variable to add or subtract. My advice would be to pick the smallest. The smallest, if you've got 2, or the one that's, let's just go with the smallest. Alright, so let's say we've got an equation here. We've got 6x minus 10 and 3x plus 11. So we have x's on both sides of the equation. So what we want to do is collect them to the same side. Now, as I've just said, it is easiest to rearrange with the smallest of our terms with an x in them. 3x is smaller. Now that's positive 3x. So when I move it to the other side, when I make my equivalent equation, I'm going to subtract 3x from both sides. So 3x subtract 3x, well, that's going to be 0. So those terms disappear. 6x minus 3x, well, that will be 3x minus 10. That equals 11. And then my rearranging from there is just like all my other equations. So I've got subtract 10 here, so I'll add 10 to my equation, and then finally I'll divide by 3. And there's my equation solved. Okay. Once again, the key step is to add or subtract one of the terms with our variable in it from the equation to make it equivalent, and then go from there. Just to show that it doesn't matter which one you choose, this time let's try and subtract 6x from our equation. Okay, so if I subtract 6x, I'll be left with negative 10. 3x subtract 6x, that will be negative 3x plus 11. Now I've got x on this side, so I want to move that 11. So the opposite of plus 11 will be minus 11. Negative 10 minus 11 will be negative 21 equals negative 3x. Divide both sides by negative 3. 7 equals x. I still get the same answer there. Okay, so minus 11 divide by negative 3. Same answer. The only reason why using the smallest term, like we did in that first example, might work better is because it means you avoid using too many negative numbers. If you're confident with your negative numbers, it doesn't really matter. If you're not so confident, just pick the smallest term and then move it from there. Alright, so now sometimes you might have to expand some brackets before you solve. Like in this one here. And then once you expand the brackets, then you can collect your like terms. So expanding here, 4x minus 12 equals 2 minus 10x. Right, Now, in this case, which term do I move? The 4x or the negative 10? Again, the smallest term is best to move. In this case, the smallest is actually negative 10. So we'll add 10x to both sides. $10x. So 4x plus 10x is 14x. Minus 12 equals 2. Then I can add 12 to both sides. So 4x equals 14. Divide by 14, x equals 1. So once again, not too bad. Again, just make sure you collect your like terms properly. Check your work for errors. That one looks very good. But this example just involved doing some expanding first. All right, this final one. If we have an equation where we have one fraction equaling another fraction, this is where something that we call cross multiplication can be an excellent approach to use here. What we're basically going to do is draw a cross over our equal sign, and we're going to multiply along those lines there. So how it will work is we've got 2x plus 10 times 3, so 2x plus 10 equals 4 times 5 minus x. Now what we're doing here is basically multiplying each side by our equation by both denominators. So multiplying both sides by 3 cancels out those ones. And then when I multiply both sides by 4, and times 4, that 4 and that 4 cancel each other out too, and you're just left with 3 times 2x plus 10 and 5 minus x times 4. So we are just doing some rearranging there. We're just using a cross to simplify that process a bit. And then we can expand. 6x plus 30 equals 20 minus 4x. If we add 4x to both sides, 10x plus 30 equals 20. Subtract 30 from both sides. 10x equals negative 10. Negative 10, not negative 110. X equals negative 1. All right, and there's my solution to that equation. Let's draw those steps in. So expanding. From there to there, we added 4x. From there to there, we subtracted 30. And then that last line we divided by 10. And students, once again, not too challenging. With that one, just use your cross multiplication if you have both sides being fractions. And then you can expand, collect like terms, and solve as you normally would. So students, after watching this video, you should be able to recognize like terms and equations and solve a variety of equations where the variable is on both sides of the equation.